Section 9.5, Managing External Access with Kubernetes Ingress. Spring Cloud Gateway helps you define an edge service where you can implement several patterns and cross-cutting concerns at the ingress point of a system. In the previous sections, you saw how to use it as an API gateway, implement resilience patterns like rate limiting and circuit breakers, and define distributed sessions. In chapters 11 and 12, we'll also add authentication and authorization features to Edge Service. Edge Service represents the entry point to the Polar Bookshop system. However, when it's deployed in a Kubernetes cluster, it's only accessible from within the cluster itself. In Chapter 7, we used the port forward feature to expose a Kubernetes service defined in a Minikube cluster to your local computer. That's a useful strategy during development, but it's not suitable for production. This section will cover how you can manage external access to applications running in a Kubernetes cluster using the Ingress API. Note: this section assumes you have gone through the tasks listed in the previous Polar Labs sidebar and prepared Edge Service for deployment on Kubernetes. Section 9.5.1, Understanding Ingress API and Ingress Controller. When it comes to exposing applications inside a Kubernetes cluster, we can use a service object of type cluster IP. That's what we've done so far to make it possible for pods to interact with each other within the cluster. For example, that's how catalog service pods can communicate with the PostgreSQL pod. A service object can also be of type load balancer, which relies on an external load balancer provisioned by a cloud provider to expose an application to the internet. We could define a load balancer service for Edge Service instead of the cluster IP one. When running the system in a public cloud, the vendor would provision a load balancer, assign a public IP address, and all the traffic coming from that load balancer would be directed to the Edge Service pods. It's a flexible approach that lets you expose a service directly to the internet, and it works with different types of traffic. The load balancer service approach involves assigning a different IP address to each service we decide to expose to the internet. Since services are directly exposed, we don't have the chance to apply any further network configuration, such as TLS termination. We could configure HTTPS in Edge Service, route all traffic directed to the cluster through the gateway, even platform services that don't belong to Polar Bookshop, and apply further network configuration there. The Spring ecosystem provides everything we need to address those concerns, and it's probably what we would do in many scenarios. However, since we want to run our system on Kubernetes, we can manage those infrastructural concerns at the platform level and keep our applications simpler and more maintainable. That's where the Ingress API comes in handy. An ingress is an object that manages external access to the services in a cluster, typically HTTP. Ingress may provide load balancing, SSL termination, and name-based virtual hosting. Kubernetes this link. An ingress object acts as an entry point into a Kubernetes cluster and is capable of routing traffic from a single external IP address to multiple services running inside the cluster. We can use an ingress object to perform load balancing, accept external traffic directed to a specific URL, and manage the TLS termination to expose the application services via HTTPS. Ingress objects don't accomplish anything by themselves. We use an ingress object to declare the desired state in terms of routing and TLS termination. The actual component that enforces those rules and routes traffic from outside the cluster to the applications inside is the ingress controller. Since multiple implementations are available, there's no default ingress controller included in the core Kubernetes distribution. It's up to you to install one. Ingress controllers are applications that are usually built using reverse proxies like Nginx, Haproxy, or Envoy. Some examples are Ambassador Emissary, Contour, and Ingress Nginx. In production, the cloud platform or dedicated tools would be used to configure an ingress controller. In our local environment, we'll need some additional configuration to make the routing work. For the Polar Bookshop example, we'll use Ingress Nginx, see this link, in both environments. Note: there are two popular ingress controllers based on Nginx. The Ingress Nginx project, see this link, is developed, supported, and maintained in the Kubernetes project itself. It's open source, and it's what we'll use in this book. The Nginx controller, see this link, is a product developed and maintained by the F5 Nginx company, and it comes with free and commercial options. Let's see how we can use Ingress Nginx on our local Kubernetes cluster. An ingress controller is a workload just like any other application running on Kubernetes, and it can be deployed in different ways. The simplest option would be using kubectl to apply its deployment manifests to the cluster. Since we use Minikube to manage a local Kubernetes cluster, we can rely on a built-in add-on to enable the ingress functionality based on Ingress Nginx. First, let's start the Polar local cluster we introduced in Chapter 7. Since we configured Minikube to run on Docker, make sure your Docker engine is up and running.
See this code?
Next, we can enable the Ingress add-on, which will make sure that Ingress Nginx is deployed to our local cluster.
See this code?
In the end, you can get information about the different components deployed with Ingress Nginx as follows.
See this code?
The preceding command contains an argument we haven't encountered yet, ningress nginx. It means that we want to fetch all objects created in the Ingress Nginx namespace. A namespace is an abstraction used by Kubernetes to support isolation of groups of resources within a single cluster. Namespaces are used to organize objects in a cluster and provide a way to divide cluster resources. See this link. We use namespaces to keep our clusters organized and define network policies to keep certain resources isolated for security reasons. So far, we've been working with the default namespace, and we'll keep doing that for all our Polar Bookshop applications. However, when it comes to platform services such as Ingress Nginx, we'll rely on dedicated namespaces to keep those resources isolated. Now that Ingress Nginx is installed, let's go ahead and deploy the backing services used by our Polar Bookshop applications. Check the source code repository accompanying this book, Chapter 09/09end, and copy the content of the Polar deployment/Kubernetes/platform/development folder into the same path in your Polar deployment repository, overwriting any existing file we used in previous chapters. The folder contains basic Kubernetes manifests to run PostgreSQL and Redis. Open a terminal window, navigate to the Kubernetes Platform Development folder located in your Polar deployment repository, and run the following command to deploy PostgreSQL and Redis in your local cluster.
See this code?
You can verify the results with the following command.
See this code?
Tip. For your convenience, I prepared a script that performs all the previous operations with a single command. You can run it to create a local Kubernetes cluster with Minikube, enable the Ingress Nginx add-on, and deploy the backing services used by Polar Bookshop. You'll find the createcluster.sh and destroycluster.sh files in the Kubernetes Platform Development folder that you have just copied over to your Polar deployment repository. On macOS and Linux, you might need to make the scripts executable via the chmod +x createcluster.sh command. Let's conclude this section by packaging Edge Service as a container image and loading the artifact to the local Kubernetes cluster. Open a terminal window, navigate to the Edge Service root folder, Edge Service, and run the following commands.
See this code?
In the next section, you'll define an ingress object and configure it to manage external access to the Polar Bookshop system running in a Kubernetes cluster. Section 9.5.2. Working with ingress objects. Edge Service takes care of application routing, but it should not be concerned with the underlying infrastructure and network configuration. Using an ingress resource, we can decouple the two responsibilities. Developers would maintain Edge Service, while the platform team would manage the ingress controller and the network configuration, perhaps relying on a service mesh like Linkerd or Istio. Figure 9.6 shows the deployment architecture of Polar Bookshop after introducing an ingress.
Figure 9.6. The deployment architecture of the Polar Bookshop system after introducing an ingress to manage external access to the cluster.
Let's define an ingress to route all HTTP traffic coming from outside the cluster to Edge Service. It's common to define ingress routes and configurations based on the DNS name used to send the HTTP request. Since we are working locally, and assuming we don't have a DNS name, we can call the external IP address provisioned for the ingress to be accessible from outside the cluster. On Linux, you can use the IP address assigned to the Minikube cluster. You can retrieve that value by running the following command.
See this code?
On Mac OS and Windows, the Ingress add-on doesn't yet support using the Minikube cluster's IP address when running on Docker. Instead, we need to use the Minikube tunnel -- profile polar command to expose the cluster to the local environment and then use the 127.0.0.1 IP address to call the cluster. This is similar to the kubectl port forward command, but it applies to the whole cluster instead of a specific service. After identifying the IP address to use, let's define the Ingress object for Polar Bookshop. In the Edge Service project, create a new ingress.yml file in the K8s folder.
Listing 9.20. Exposing Edge Service outside the cluster via an Ingress.
At this point, we are ready to deploy Edge Service and the Ingress to the local Kubernetes cluster. Open a terminal window, navigate to the Edge Service root folder, Edge Service, and run the following command.
See this code?
Let's verify that the Ingress object has been created correctly with the following command.
See this code?
It's time to test that Edge Service is correctly available through the Ingress. If you're on Linux, you don't need any further preparation steps. If you're on Mac OS or Windows, open a new terminal window and run the following command to expose your Minikube cluster to your local host. The command will continue running for the tunnel to be accessible, so make sure you keep the terminal window open. The first time you run this command, you might be asked to input your machine's password to authorize the tunneling to the cluster.
See this code.
Finally, open a new terminal window and run the following command to test the application. On Linux, use the Minikube's IP address instead of 127.0.0.1.
See this code?
Since catalog service is not running, Edge Service will execute the fallback behavior we configured earlier and return a 200 OK response with an empty body. That's what we expected, and it proves that the Ingress configuration works. When you are done trying out the deployment, you can stop and delete the local Kubernetes cluster with the following commands.
See this code?
Tip: for your convenience, you can also use the destroycluster.sh script, available in the Kubernetes platform development folder of your Polar deployment repository, that you copied earlier from the book's source code. On Mac OS and Linux, you might need to make the script executable via the hmod +x destroycluster.sh command. Good job! We're now ready to make Edge Service even better by adding authentication and authorization. Before configuring security, though, we still need to complete the Polar Bookshop business logic for dispatching orders. In the next chapter, you'll do that while learning event-driven architectures, Spring Cloud Function, and Spring Cloud Stream with RabbitMQ.